Hi, my name's Jesse. You can find me on IRC on various IRC networks as Obra. As got mentioned, I somehow indeed did end up getting signed up for 4 talks. So a couple of things that you've probably already noticed that I'm an American, and that means a couple of things. One, I tend to talk kind of quickly, and sometimes I'll use strange foreign idioms. I will use words that might make no sense at all. If I say something and it doesn't make sense to you, it probably doesn't make sense to anyone. And you should wave your arms or shout at me or do something so that I'll rephrase, go back, and make it more understandable. Like I said, I'm an American. I'm used to people interrupting me. If you have questions, feel free to just ask them or raise your hand or what have you. Good so far? Okay then. So the thing I'm talking about today is called SD. It's a bug tracker. It's a peer-to-peer bug tracker. And this all came about because, well, I found myself responsible for a tiny little software company called Best Practical. Our primary business is making issue tracking software. That is what I will be talking about in Auditorium D in 40 minutes. But like, as you might expect, our software, well, it has some bugs in it. Because all software has bugs. Because all software is made of bugs. There is nothing in software that is not somehow a bug. Which makes bug tracking near and dear to a lot of hackers' hearts. I spend a lot of time on airplanes. I spend a lot of time at conferences where the Wi-Fi doesn't work so well, where I can't say get to my server. This makes cloud-based solutions or even internally hosted solutions less than wonderful. But I do actually need to keep tabs on what's going on. And the problem is that because I'm the boss, because I'm actually responsible for everything, there's nobody I can claim, oh, I was at a conference and someone else can cover it to. So I spend a lot of time without internet access and a lot of time needing to get work done when I don't have working internet access. Like almost everyone here, I started off with text files. I figure, well, I'll just open up an editor and I'll write down the things that need doing and the things that got done, and I'll sync them up later. Has anyone here tried that as a way to keep track of what needs doing? How'd it work out for you? Well, when it stops scaling so well, usually you do this. You check the text file in a version control system, so you at least know what it looked like yesterday. And that's better, but it's still not good. From there, I went somewhere kind of crazy. Went to an IMAP server. So at the trivial end, this can just be an email message that has a bug in it. At the super scary high end, one of the issue tracking systems we actually built an IMAP front end to that basically backends into code so that all of your bugs show up as mail messages, so you can take them offline, you can drag them between folders to perform actions on them, but that's still not really right for bug tracking. I've tried keeping a feed reader open that has feeds of all of the bugs that I know about. I've tried running RT, the ticketing system we make, on my laptop. I've tried just keeping a browser window open with a view to all the stuff I need to be doing. And then invariably the browser crashes. And then I don't know what I'm supposed to be doing. So none of this stuff really dealt with any of the problems that we actually have. And so we ended up building this thing called SD. At its heart, SD is it's a bug tracker. It keeps track of bugs. The cool thing about it is that it's designed from the beginning to be distributed. It's designed to, well, do lots of things. It's designed to track bugs, of course. It has a command line. It has a web interface. You can script the command line. It has a REST interface to the web so that you can script the web side of things. Of course, it works offline. It supports attachments and comments and customizable properties, and you can set custom workflow for each type of bug. Well, I'll get through all of this, but it's a fairly full system. When you are building a distributed system, there is this set of things that you need to keep in mind. Basically, they are the sort of central guiding principles about how distributed systems work or don't work. I didn't come up with these. These are created by some guys you might recognize. So, does anyone know where these guys' names come from? And anyone recognize any of these names?
Yes.
Yeah, they're the people who founded Sun and created Java. These are people who know distributed systems. So they have spent a lot of time with many distributed systems. So I used to be able to actually pull this off and claim that these were the principles of distributed computing, but I can't get through them without laughing anymore. So we're just going to walk through them. The network is reliable. There is no latency. Bandwidth, never a problem. Networks are secure. Transport doesn't cost anything. Every node on the network you can treat as being the same. Network topology, you can treat as being essentially static. And there's a single administrator. So these things were in fact created by these guys who some people might argue know distributed systems, and some people might argue don't know distributed systems. But they're not called the principles of distributed computing. They're called the fallacies of distributed computing. Each and every one of those is a lie. If you build a distributed system and you depend on any one of those statements being true, you're screwed. It just doesn't work. Network, of course network isn't reliable. So SD doesn't actually depend on network existing at all. It's, you can sync over SneakerNet. Any way that you can get data from point A to point B, whether it's networked or non-networked, we can use it with SD. Latency is incredibly painful. I end up in a lot of weird places with ping times over a second to where I need to get back to. And trying to use an interactive system over that, don't work. SD is designed to run on your laptop. SD tries to be really smart about how it uses bandwidth. If there's a change set that it knows it's already seen, it doesn't need to get another copy of it as it's doing a sync. SD just doesn't depend on a network security layer because it's running sort of up from there. Topology, network topology is never static. Everybody moves around. No one is ever coming from the same place. So, and of course, there is no administrator for any kind of internet connected system. Lots of people who believe that they're the administrator of a system, but not for anything that's distributed. You just can't do it. If you need that kind of thing, SD syncs to a lot of centralized systems, and you can implement policy there. And transport costs money, same thing as latency. You can actually move SD over USB keys, and that's how a bunch of people I know actually trade their bugs back and forth. And I think the most important point when you're trying to build a new distributed system that you're trying to replace existing systems for is that you have to assume that no one's going to walk away from the systems they're using today. SD is designed to sync with a bunch of existing issue tracking systems, and I'll talk about that in a little bit. Trying to just sort of walk in and drop on a system that replaces everything everyone knows never goes smoothly. So SD is designed to sort of work the way that you do. It's designed to let you sync with the people you actually work with. It's designed to let you sync over a local network. It's designed to let you sync over shared servers. The basic way that this all works is you start by cloning another project's bug database. Usually over HTTP, you can do it over anything else that you can yank a bunch of files over. So if you want to rsync things or SCP things or what have you, that works too. You do some hacking. While you're doing hacking, you can pull change sets from anybody you're working with. Whenever you want to, you can publish your own replica of a database. So that's basically, you can say, here is my version of the bug database for foo product, and anyone who wants to can pull your changes from there. In a sort of native SD world, topology doesn't really matter. You can sync with anybody, with someone you're working with in a cafe today, and tomorrow with someone you've never met but who works on the same project, and eventually change sets all propagate to the right places. This is usually the point where someone starts saying, well, but conflicts. You're going to get conflicts between changes, and then it's all going to explode. And so this is actually one of the sort of interesting things that we've done. Are people here familiar with CouchDB? So CouchDB is a sort of a generic distributed database. And it has magic conflict resolution. Two people can make changes in different places, and every replica of Couch that gets those two changes, it'll resolve the conflict the same way. Talking to a couple of the Couch guys, the way that they do that is they always pick A. That's their magic. So what we do with SD and Profit, the database underneath it, is we actually treat a conflict resolution as something that's worth reporting, something that's worth carrying around with you. So when SD sees a conflict that it doesn't know how to deal with, it prompts you. It says, hey, you changed this to this from new to open, and Bob changed this from new to resolved. Which one is it? And you make a manual choice. And that choice gets recorded and propagated. And so what happens is, over time, things that are contentious, there are lots and lots of people who get prompted and say, should we do this or should we do that? Whereas for things that aren't contentious, SD says, oh, well, I've prompted 10, I've seen 10 resolutions for this and they all picked side B. I'll go with side B. What was really surprising to us is that after playing with this and dropping it into a simulator where we sort of built big arbitrary networks of lots and lots of people making lots and lots of changes, it always settles out clean. We haven't actually managed to break it since the third day, which was kind of neat. All of the conflict resolution stuff is completely pluggable, so if you had custom policies you wanted to implement, that's very doable. But it does sort of just fall out as things that tend to resolve themselves. One of the things about the database underneath SD is that it's transactional. It records every change set, just like any kind of version control system. So you can actually see who made which resolution decision at which time, which means that even if if SD picks the wrong side of things, you know what choice was made and by whom and when. Questions so far? Making reasonable amounts of sense so far? Okay, I see a couple of people nodding. So the basics of using the command line with SD. The trivial thing is you run SD. It will throw you up a shell. The shell has these sort of requisite, here, tell me about your license. Give me some online help. The first thing you're probably going to end up doing is running help. And help is going to walk you through an intro, how to search, how to create a database, how to change your configuration, how to change your database properties. If any of you are running a recent-ish Debian or Ubuntu, SD should be packaged. So if you want to play around while I'm talking about things, you can. So anyway, initializing a new project, SD init. It's basically going to create a completely empty bug database. There is nothing exciting about this. The first thing you'll want to do after initializing an empty database is run settings. And settings allows you to set, oh God, I apologize. That's absolutely horrible in here. It allows you to set up sort of project milestones, project components. Is this the UI? Is this the command line? Is this the email system? It allows you to set what the statuses are for bugs in your system. So when we're syncing to foreign systems, Google Code has one set of nomenclature, Track has another, RT has another, and your project may have something completely custom. It lets you set defaults for all of these things. It lets you set common ticket properties. One of the things about a distributed system is you can't depend on everybody always having the exact same schema. If everyone has to have the exact same schema, two people make different changes to the schema in different places, and it all goes to hell, and it becomes impossible to use. And so the way that Prophet, the database underneath SD, and a bunch of other similar systems work is they have the concept of common properties. The things that we expect to be there, the things we're going to be displaying by default. But if we see something strange, we just roll with it. You basically have to assume when building a distributed system that bad data is going to sneak in. You can't assume that every ticket is going to have a status that you know is a valid status. You can't be doing your error checking on, you should do error checking and validation on initial input, but you can't assume that every other copy of the software is always going to be doing that same validation and is always going to be doing it right. So you need to assume that your database might have bad data inside. And you need to, when you're building an app, you basically need to protect your user both from data that's coming in from the outside world and data that's already inside the app. Configuration. There's lots. This screenshot is actually slightly out of date. It now looks exactly like Git's config file. We, of course, have aliases. We've got a list of all the other database replicas that you know about that you've seen. You can, is that a hand halfway up or? No, okay. So it basically, it's where you set your email address, what, how you want to show tickets in ticket listings by default, where you might want to be cloning copies of a ticket database from, where you might want to push yours to at the end of the day. Once you've actually gone and done a little bit of setup, now you can actually, well, not really create bugs, but record bugs that are already in your software or tasks or what have you. So running ticket create, it's going to pop up a trivial form. You can fill in values. I talked about common values a moment ago. If you put in a status or a milestone or a component that isn't something that is listed in your config file as a possible value, it's going to come back and warn you and say, did you really mean to set that to status openy instead of open? And you basically have to say, yes, I really did mean to put in that kind of crazy data. You can add ticket comments below this is a pretty standard text editor based form. You can also do this using parameters on the command line. Once you have some bugs in the system, you can list them. And listing and searching are basically the same thing. You can specify sets of properties and things those properties need to match. By default, it's going to group your tickets by milestone. You can group them by other stuff too. When you look at an individual bug, you see its local ID, its globally unique ID. So this is something else important about distributed systems. If you have a system that's running in two places and they're not connected by the network, it's impossible to have globally unique simple integers. You no longer have a ticket number 1, because if I create one and someone else creates one at about the same time, they might get the same number. So there's shorthand for what the local ID for a ticket for anything is, and then it's globally unique UUID. They're SHA-1 based UUIDs, so they're actually truncatable if that matters to you. But current ticket properties, where the ticket originally came from, and then ticket history. And so the history includes all properties of the ticket, all comments on the ticket, all attachments on the ticket, and every history entry for an individual property change records the old value and the new value. So a create is all changed from blank to something else, blank. And what this means is you actually have a full history. You can play back history sort of arbitrarily. If you've worked with basically any shared, I have not actually seen a bug tracking system that fully records all history in a user visible way. With RT, it's possible to reverse engineer. Track actively loses history. Google Code actively loses history. Debugs is actually an interesting special case that I will hopefully talk about later. There is a Debugs replica for SD coming for DebConf, being written by a former coworker of mine. GitHub doesn't track history. The one component of GitHub that is not backed by Git is their issue tracker. Even their paste bot is backed by Git, but their issue tracker doesn't track history. We can, of course, update tickets. You can do trivial command line based updating if you just want to set a couple of properties quickly. You can update an ID and it pops up a text editor, and you can twiddle things in the text editor and save it. Because SD has this database underneath that's tracking things by change set, like any good version control system, we have a log command, which means that I can come back after 3 days and say, show me what's happened. And I can get a walk back of all of the history of what's happened since I last poked around. If you're a Git user, there's some trivial Git integration for SD. Git SD will automatically set the SD replica path and fire up SD from anywhere within your Git checkout. It's pretty brain dead simple. It'll auto-configure based on your Git config. There is a Darks plugin that works the same. We haven't had anyone contribute us a Mercurial plugin. Questions so far? Okay. SD's web interface. At this point, I sometimes have people saying, but you said it's offline and local. So SD uses a trick that dates from about 1994 from Satan. It's got a local micro server. It's a tiny little pure Perl web server. Doesn't do anything special. But if you type SD browser, SD will launch the web server and then launch your browser. It has a homepage. The homepage shows you things like active tickets for the current milestone, and then little thermometers for broken down by component, by status, and by milestone. Creating a ticket in the web UI has the sort of standard fill in all the same fields as in the text forms. Simple faceted search, so you can drill down and find tickets by any of a number of different categorizations. Looking at individual tickets, it's like a web version of the text console. It shows you the various properties. Update and create actually share a trick. Before I talked about common properties and showed that off in the config file. So when you start typing something into any of the fields that are backed by a set of common properties, SD will basically give you a little Ajaxy autocompleter of all the possible values that it thinks you might mean. And so it tries to push you hard toward using a common value rather than making one up. Comments. Of course, it records all the comments that you enter. It shows them in a little history form. History, like I said before, it shows everything that happened from day 0 on each individual ticket, broken down by change set, who did it, what replica they started off at, what property got changed, and set 2 is set from nothing to this. Here status actually changed from something, owner got set from nothing to something. So for actual collaboration, which usually makes things a lot more fun, folks using SD, I described before, any topology works. You can sync with anyone who's got a clone of the same database. Updates propagate around. Usually you start off with clone rather than init. So what clone does is it says, I want a copy of that database. I want all of the change sets from that database. And it gives you a local copy of everything that's happened in history. It basically makes a full replica of another database. And it's a simple command line command. And then it runs the sort of stupid, really? Okay. Okay. All right, so clone gives you a stupid progress bar. Pull. Pull is like clone, except it's what happens when you already have a base replica. And so it basically incorporates any change set you haven't already seen. Pull looks just like clone. Publish. Publish is when you say, okay, I actually have done enough useful stuff that I want other people on the project to be able to get at the changes I've made. And so publish can publish over anything that rsync supports, so local file or SSH or RSH, God help you. And it exports a full copy of all your change sets along with a static HTML version that is suitable for browsing by someone who doesn't care to install SD. SD comes with a hackathon mode. If you happen to be in a room with a bunch of people who are working on the same project, each of you can run SD server and then run SD pull local, which uses Bonjour or multicast DNS or whatever it's called this week to figure out who else on the same local network also has a clone of the same database as you and pull in all their change sets. It's simple, it's easy, it's a lot faster than trying to use upstream network. So at this point, well, you already have a bug tracker, right? That's okay. I use at least 2 others in everyday usage because I wrote them. And so from the ground up, we designed SD to deal okay. So the first implementation of a foreign replica type we made was for RT, ticketing system I'm talking about in 15 minutes. It uses the RT client REST cpan library. Nothing changes in the server. This can run against any RT instance. One of our design goals for foreign replica support was it shouldn't piss off the remote admin, and they shouldn't have to do anything special to let you use it. If you have to make them install special software to let you use your offline bug tracker, you lose. So for Hiveminder, we built on top of NetGifty, cpan module. For Track, I looked around, and Track doesn't actually ship with a web services API. The best info I've seen from the author of Track is that if you want a Track to ship with a web services API, you should fork it. I'm not in the business of forking Track. I am a dirty Perl hacker, and so I ended up writing NetTrack. NetTrack is a client library that fakes a REST interface off of Track's existing web UI. Using feeds where we can and using flexible form scraping where we can't. We had to do something similar for Google Code. We built Net Google Code. For GitHub, we were able to use Net GitHub, which already existed. Redmine uses Net Redmine. There is a debugs implementation that I've been promised will exist by DebConf this year. If you're interested in making SD talk to something else, it's about 200 lines of code for each of these. It's not too bad. One of the things about using SD against a foreign bug tracker is that it only works in a star topology. Basically, you can think of it as a client for a foreign bug tracker. It's completely okay for for SD to be a gateway to an SD mesh of replicas, but you can't have 2 SDs from the mesh talking to that upstream track. These slides will be online, so the little command lines at the bottom will be easier to get at. Like when working in SD, clone, 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 clone. What SD does when you clone is it reverse engineers a database history, because not all of these things actually tell you everything about the history of each object. We basically have to take what they tell us and reverse replay it to try. And reverse replay it to try to get a proper history. When we're pulling to get updates from a remote server, it only has to do a partial history. Working with a foreign system, you have to push. So push is basically take my change sets and send them up to the foreign system. And the difference between push and pull is that for push, you, the guy at the far end from the server, is making the conflict resolution decisions for the server. SD figures out what needs to get sent up, and then records a bunch of information so that the next time you push, it doesn't try to push the same change sets. So to install SD, and I'm going to have to skip over some of these slides because we got cut down a bit. So SD uses a whole bunch of cpan modules that really shouldn't make you afraid. It's okay. We have this new concept. We call it one-tweet installers. And so basically all you need to do is run that. You don't need to run it as any kind of super user. Basically it downloads a tarball containing all of the source code you need and ordered build instructions, and drops it into the SD directory in your home directory. You do need a C compiler. You need Perl 5.8. You shouldn't need a C compiler real soon now. We've made the last pure C dependency optional. But no prompts, no dependency hell. And I'm just, yeah. That should scare you a little bit. That was the first version of SD, and it's 123 dependencies. Thankfully, a little bit of refactoring cuts that more than in half. So this is all the stuff about how the installer works, which if we had more time would be cool to talk about. If you want to know what's wrong with SD, use SD. Or if you don't want to use SD, you can just point your browser at the SD bug database. The underlying database, we've tested it up to like 100,000 records, and indexing really doesn't matter at that small a scale on even a modern laptop, but we do need reasonable indexing support in the database. Change sets aren't yet PGP signed. There's a bunch of interesting stuff around doing that safely and reasonably, and I don't want to push a crypto model into the field without it actually working right. It's really, really, really irresponsible to deploy bad crypto. And once we do that, it's time to get 1.0 out. And I'm sorry that ended up a little rushed. So
we have just 5 minutes.
Yes.
You looked into using Git as the backend database?
We actually started off using a version control system as the backend database. And what we discovered really quickly is that the property you want in a version control system is coherent whole versions of the entire system at one point. And what you want in something like a bug tracker or a database is you really want to make sure you capture every change in every change set. And so it turns out to be a weird little impedance mismatch. At this point, we could shove it into Git, but it's not like, the only thing it wins you, we wouldn't want to use Git's merge tracking and Git's resolutions, and that would be the cool reason to want to. We've looked at a bunch of the things like TickGit that try to use Git as the back end, and they all feel funny to me.
Which version control system did you try to use?
So in the very beginning, we used SVK. This was a while ago now. And my business partner was actually SVK's original author. The reason we used SVK is because I knew that I would get very good tech support. But it was sort of, at the time, you can bludgeon anything into a property database. It doesn't make it fun, though.
Yeah. It was just wondering, because the backend you use is something written in Perl, right?
The backend we use is actually, the backend we actually use is SQLite. There's also a file system backend. And the backend is the code is in Perl, but the change set format is JSON, and it's a pretty simple schema.
So, but then the file system backend, you could write a different application that accesses directly the file system backend without having to go through a Perl API or something.
Sure, you could. I mean, it's completely possible to implement all of this in any reasonable language.
Even a graphic client like what will be presented in the next talk.
I'm really bummed out that I can't see the next talk because it's very clearly very related. Which one of you is giving the next talk? We should chat later sometime.
Who's using SD?
Lots of people are using SD as a client most use of SD is using it as a client for some centralized system, and a lot of it is just random people using.
Are there any projects that try to enforce its use?
Not that I know. I mean, one of the things that's really nice about SD for me is that I don't have to enforce its use. Yeah. Because I like having in any kind of community project, it is useful to have a centralized canonical master. SD, that's not really its goal. which means that, for example, the only mail gateway that I have for creating tickets in SD is a horrible, horrible hack, because I just sync it to RT. And so there are a bunch of us who, yes.
Last question.
He's not proud enough to mention it, but he's working on OS and CCM. I mean, Olivier here. Do you have an implementation of this protocol in SD? Because it's probably going to get you interaction with all the web drivers like Mozilla and Fusion Forge.
Not yet, but certainly, I mean, the other one of those protocols that I know is getting a little bit of traction is is Launchpads. Launchpad basically wrote a Bugzilla implementation and a track implementation.
So we have also a Launchpad.
Yes. Excellent.
I'm sorry, but maybe you have.
Three questions. I did one.
It's okay.
No, but he has room to talk in another room, so I don't want to be rude, but.
So please, ask the question rather than.
I missed the beginning of the talk, so you might have answered that. Are you aware of other applications that use Prophet as the
Not. Only anecdotally, nothing real. The other app that we really want to be building on top of Prophet is a peer-to-peer BBS. And this is something I'd actually like to not talk about on camera. But I'd be happy to chat about later. Thank you. I'm sorry this was abbreviated and